Hello. Okay. So my microphone monitor is just like delay again. I think last time we had uh too we had the microphone setup too loud, and last time I just like just come back from on-site work. But anyway, I should have said. I mean, no. I should. I should. I should say to you, Merry Christmas tonight, right? Tonight it's Christmas Eve, so yeah. Merry Christmas. But I have I have my own agenda, so yeah, not the Merry Christmas. And well, yeah, Merry Christmas. Merry Christmas, by the way. So what's important today isn't just Merry Christmas. It's also suspecting. I mean, is also a candidate for Sir Isaac Newton. Yes, the father of modern science, modern physics, actually, modern physics. The father of modern physics, Sir Isaac Newton. Rules of motion, gravitation, and calculus. Also, light spectrum. Three things. These three things are keys. Happens when we talk about life of Sir Isaac Newton. I will just talk a little bit about him. That he was offered by head of the church in like his teenager, and that offer was to promote him to become bishop of the church, and he declined, but he got it anyway because of his title. So he also got knighted by a Queen Elizabeth. I think. I'm sorry, but so yeah, he is also bishop and also knight at the same time, which is like which means he has privilege lower than just the Pope himself. Anyway, that's the miracle of someone who was born at the night of Christmas. Yeah, that's about it. Then I'm going to talk about his birthday. Now, let's go back to our reinvention. By the way, I have noticed that my English is like so bad that I shouldn't say I shouldn't talk in English anymore. But what do you say? I want to, so no one should stop me. Let me look at my YouTube studio and we will be all good. Okay, so the stream is online. Welcome whoever come to the stream, and the madness will begin right this moment. Okay, this is my backend. So okay, so this is the API I was working on this evening. But we are not talking about it tonight. Right. So, yep, Reinvent ML. Oh, it doesn't exist anymore. Why? Open workspace. Why doesn't it exist anymore? Yeah, think. Oh, so because they change where the file lives. Hey, one thing I didn't do is log into my Discord. My Discord server. Yeah, live stream. Hello. Okay, so yeah, Fuji used fade to cross fade the picture, and the alpha channel didn't add up to 50. That's not good at all. By the way, I used to have another picture behind that jumpy head. So it's not transparent. Alright, so what I'm going to do is to bring up the chat, because Discord, no, actually OBS cannot because OBS cannot like show you the chat. Let's reset it up real quick. Right. Wait. I already have chat. Okay. Yeah, let me set it up real quick. And I love to show this one to you. Where is it though? Over this way. Wait, what can I? Hey, pop out. Live. Yeah, just get everything. Okay, so sign to chat? No, I don't need to sign. And also the width is about 200, and the height, well, that's perfect. Oh, 200 is not perfect. 4 then 400. Yep, that's perfect. I'll just put it around here. Yeah, around here. I want you to see the date, so yeah, it will be over here. I thought I see someone chat, but where is it? Hey, I think I saw you somewhere. Anyway, I'm sorry. I'm sorry that didn't I didn't respond in time. Oh, the message is retracted. Anyway, welcome to the stream, Gundam. Black Moon. Yeah, the Black Moon. Wait. Wait, what? No folder open. Yeah, because it's just like untitled file, I guess. My project. Ooh. Okay, this folder. Yes. This one. Reinvent ML. Actually, it should be reinventing ML. Now, last time we talked about this picture. So reviewing Explorer. Yeah, this madness. Wait, I should have like used Krita. Anyway, I don't think I will keep picture. So paint. So my voice attack is too fast. That that my virtual filter don't want to work with it. Anyway, so last time we talked about how division isn't okay for computing large data, and this sigmoid function, well, in reality it's close to sigmoid function, the response of the neuron, but yeah, like linear function is okay, so either one is okay. Now the axon state reading, this is problem we're talking about it today. Let's use Krita. Krita is my favorite drawing software, so you see it a lot. And the reason, clearly, because it's free. It's open source. That's all. I think I will go with this setup. Okay, now so we have this. Let me put it in Krita. Yeah, just this one. Okay, so now we have this. We are talking about axon state. Boolean. What is Boolean? Anyone knows what is Boolean? I think I should. Oh, I have that palette. Okay, I have that palette. Fill to X. No, not X. D. Fill it all black, and then brush 2. Now let's try this one. Should I use pencil? Let's start up. Wait, what? They use pencil. Wow, not different. Pixel art. Yeah, should I use pixel art? What is this? Dithering. Oh, fill and detail. Anyway, let's get back to what we have. Oh, okay. It's too small, right? Anyway. Oops. Will. Full screen. Oh, Control Shift F. Doesn't work. This works. Okay. Okay, now let's talk about the number 3 Boolean. Axon state. As Boolean. What is Boolean? Bool. This is actually a person name. This is actually a name of a person. So here we go. I think his name is James. James or not? I don't know. So what is Boolean? It's actually a logic. Oh, it's George Bool. George Bool. Yeah. So George Bool is a mathematician. Was a mathematician who analyzed these things and he basically is the father of logics. This looks so similar to sigmoid functions, but it's irrational function. Yeah, rational function like this. Anyway, now let's go back to this. The Boolean is true or false. That's all. That's all it means. But the problem is, if we are using the entire integer, computer integer is int 16 means the maximum number is 2 to the power of 16 minus 1. Actually not minus 1, because we are not talking about 2's complement. We are talking about only integer. And if we don't divide, so how the hell are we going to do this? So any node, right? Any node has arbitrary amount of axon terminals. So we need to make this one compared to this one. And the only way that we can compare something is division. If we don't divide, what happened? It's not going to go anywhere, right? But the strategy can be that each axon has, I mean, each each node has, uh, it knows its own axon, right? It knows its own connections. So it knows its input. Yeah, it knows number of its inputs. So why don't you just why don't we just make it so that each input has constant multiplier. Oops. Yeah, why don't we do that? So each time it learns, it will divide, but it's just like one division each time. So what does it mean? I mean this because I'll just use abbreviation. So because because each neurons each node only change axon when a certain event happen. Because in reality we don't lose axon, we lose dendrite. We lose both. That's correct. But axons is more sturdier. Yeah, axon is much sturdier than dendrite. So the axon event only happen. So we only divide when this certain event happened. We allow division here. Division. Yeah. We allow division at the event. This is optimized. So what does it mean? It means if a neuron has like 3 axons, then the reinforcement happen. It becomes 4 axons. This is where we use divisions. Only when the reinforcement mechanism is triggered that we divide. But in most cases, we only use this multiplier to multiply the integer, and we check. So what does this mean? The input is not integer anymore. The input is now floating point. So float usually is 32 bits. And since we use float, we should, since the multiplier uses floats, we should use float all the way. I think. No, because the number of the number of nodes must, I think it must be integer. It shouldn't be float. Anyway, so why we allow multiplier? Why do we allow multiplication? Because multiplication is cheap. This in some system can be like one cycle, 1 to like I think maximum is 4 cycle. So 4 cycle mean 32 bits. That means actually it means they calculate all 4 bytes. So this is cheap compared to like 20 cycles, and in some system 100 cycles of division. So so we fix this thing. We just have this equation then, x on n, which is either 0 or 1, and it is integer. Times mouse, which is, well, in this case we should be using percentage of this, not the percentage per se. It should be ratio. It should be from 0 to, oh, by the way, I forgot about this. Okay. So this one is continuous value from 0 to the whole integer. Because like this one has more than 2 to the power of 32 numbers. because, well, it works differently. I will not go into that. Hmm. Um. Yeah. So 2 to the power of 16 is number one in most AI system. In this case, oops. The reason, well, because because the input is only 0 or 1, so uh, the strength of the signal is stored in axon. So instead of like do all these calculations, instead of having this expensive per se multiplier, why don't we just count the accents and then like use the threshold from the number of accents? So uh, the actual equation becomes out actually becomes phi is wait phi yeah phi of x is summation of every axon's value, and it compare, well, division, yeah. So if it's greater than threshold, then we should output 1 and otherwise 0. That's all. Not greater, greater or equal to threshold. And what is the threshold? Where thresh is where threshold is minimum of a minimum of maximum an. Well, this is not correct term to say. Threshold is minimum number of axons in active state. Yeah, that's all. We just fix the we just fix the problem. Oh, hold up. I'm sorry. I forgot to draw in the new layer. So yeah. Nope. Let's get back to another topic. What is it? It's reading neuron pattern. So reading neuron pattern What the fuck is that character? The reading neuron patterns means like at any moment, the brain will have a pattern of activating neurons and deactivating neurons. We read that data instead of trying to let neurons decide which data should come out. We read the actual activation state of the neurons, and then we process it later. Now, reading neuron patterns means at any state, no, at any what is it? At any window. No, I will say at any iteration, read all activating neurons. What does that mean? It means we take a snapshot. It's equal to taking a snapshot. Taking a snapshot of the brain. Yeah, at any moment, we will take a snapshot of the brain. That's all. That's all it means. So, what is this going to affect our calculation? Well, the entire snapshot means we will have 2 to the power of 16 bits, which is about 1.6 million bits. So 2 to the power of 16. Oops, I'm sorry. Uh, 65536 bits. So the brain only have this much this much brain cells available for it to activate. I mean, it doesn't look like much for a human brain, but imagine this one is like, I think it's about the size of, what is it? Not a mice. A mice has about 80,000. Mice has about 80,000. So maybe chicken. Yeah, so we only have this much neurons, but we can increase numbers of neurons later, like 2 to the power of, how about times 2? Yeah, how about we have 2 to the power of 32, which is long int. Now we suddenly have 4 okay, 4 billion neurons, but we only double the data. We only double the data. But what does this mean? It means megabits, right? So we are not talking about megabits when we are doing this kind of math. So we should divide by 8, which is 2 to the power of 3, and we will have this many bytes. It's still not much, because if we divide it by a million, see, we only have like 500 megabytes of data per snapshot, which is about, whoa, it's actually like an hour of full HD 60p 60 fps full HD 1 hour long, and that's just one snapshot. Yeah, the reason why we need that much snapshots is we need that many bits is we actually don't want to have like 5,000 bits to calculate, right? So we just need to take the database of the state. So because 2 to the 32 equals to, like, I'm sorry, 4294 967 296 4294 967 something 296 to wait 96 96 yep bits, because we have this, we are not going to like store the entire snapshot, because it's impossible it's virtually impossible for every neurons to activate all at once. And if it's like close together, a cluster of activating bits, we can just use the gzip to compress them all together. So the actual data would be not more than 20 megs. So this is around like 5 something divided by 8. Yeah. But okay, so it's about this much bytes. So if we use gzip or 7zip or like set z, what is it, z, I forgot the the algorithm. So I'll just gzip. If you use gzip or 7-zip, same algorithm by the way, uh, we will left with like at maximum 40 megabytes because the largest one will be hold on. So the largest size would be random noise, which in real life it means a person has a seizure. So we are not going to evaluate that. But random noise means the entire data will be activated 50%, about 50% without any pattern recognizable. That means, well, it just half the size. So this one is what should I call it? Billboard? No, chalkboard. Yeah, chalkboard. I should call it neon board actually. Hello Earth. Wait. Hello Earth 1711. I think your your number means something. I don't know, but welcome to the stream. Okay, I only have 30 minutes, 30 more minutes. So this life will end at the end of the brief. It will not end with me trying to code anything. So yeah, it doesn't mean that much for programmers. I forgot about this. I'm sorry. Yep, that's cool. That's about four chats. And I forgot that in this full screen mode, you guys cannot see the date and time. Okay, so yeah, this is the entire meaning of reading neuron patterns. Well, we cannot like have this much this much bits. We have double of this because no, we don't need double of it. We only need activating index. So if we had activating index, we just all good. So this means find sum of an by sum of an equals to 1, or actually find an sum an and then choose the minimum. I'm sorry. Sorry, why am I so stupid? So we only keep like state on, off, which is true or false. And then we have neuron list, which is node list, by the way. Node list equals to xn, equal to arrays of xn, array of xn where it is an equals to state, which is which has an, the sum of an less than less than half of n. Uh, 1 or 0. Yeah, so the state is I'm sorry. So the state is equals to minimum of equal to this when sum of an less than n2, it should be 0. It should be off. And when an is greater than or equals to n2, it should be on. And by this structure, we don't use this much. We only use like 200 something. Hello Sidan, welcome to the channel. This is a little bit of math, a little bit of philosophy, a little bit of biology, and a little bit of computing is math, by the way. So it's a little bit of everything because I'm designing the system. But yeah, this is about math of computer. This is computer science because ML is machine learning, so you have to think like computer. But my goal is to make computer think like us. So instead of letting each neurons choose whether the output should be like the other ML, I just ditch all of that and take every snapshot of every state. I will take the snapshot of each calculation step and then stream it, which is the next part. And then we evaluate the stream. Okay. What is this? Oh, tab. Okay. So that's as far as this topic go. We still have evaluating output streams and the secret sauce. Okay, so 5, evaluate output stream. So evaluating output stream is just like take number 4 and make video of those snapshots. Then try to recognize temporal pattern. What is temporal pattern? Temporal pattern means pattern that emerge over time. Temporal pattern. Anyone comes from any AI background, you are good. I just don't like how they do stuff. I just want to reinvent it because that's fun for me. Temporal patterns out of the stream, out of data stream. What is data stream, by the way? Data stream means video frames. And the video means of those snapshots. So yeah, that's all. The temporal pattern means pattern that emerge over time. I don't bother that much, so because you guys can hear how I say the words, so I can just go pattern that emerge over time, and you guys will understand that because if you listen though. Anyway, so evaluating output stream. The output stream is the strings of snapshots, which I just use the video as a metaphor. But it's essentially that. Then try to recognize temporal pattern, which is the pattern that emerges over time. So we try to recognize temporal pattern from strings of snapshots. And that is all, because this temporal pattern algorithm you see in like MRI analysis or like any brain scanning, any spatial scan, and like we also see it in audio processing. So I don't talk about this. I don't think I will reinvent these, because if I do, I might take like 10 years to do on my own. So number 4, no. So let's recap before we go to the secret sauce. So yeah, the axon state. The axon state as Boolean, it just basically means we set the threshold as number of activated axons for each node, and when the axon is activated to that minimum threshold, this node will activate and then send it to every single dendrite that it has. Um, so it it means if it gets to the threshold, it will activate 100%. Then we send that. Then for each step of the calculation, we take a snapshot. We take snapshots. So the so this AI doesn't work like how other AI want to work. The other AI just like send the data in and try to suggest output for the next layer, 100 layers, 200 layers, 1 million layers, and then just evaluate the statistics out of it to give you the output it thinks that you want. I don't want to do that. I just want to take all the snapshots of every iteration and string it together, and then push all these data stream into the preprocessor. Not preprocessor, actually. The data processor, the stream processor. So it will recognize the string of states. What does it look like? Well, it looks like you are watching anime and you understand the context in the anime. That's all. It looks like that. Basically that. And if you cannot think about it, here is what I'm talking about: strings of data. Strings of data. String of data is you have a thread and you have cards here. Each card has its own value assigned to it, and you hang it in the strings. So hang it on the strings, and then you look through it one by one. This is the strings of data, and by looking, this is the stream of the string. So that's all. It's as straightforward as that. That's stream computing. Now let's talk about the secret sauce before I go. I only have 20 minutes here. What is the secret sauce? You know, our brain connects to, our neurons connects to organs in the body, and each organ can perform something. And sometimes it releases chemicals. Sometimes it creates enzymes. And these enzymes or these chemicals affect how neurons work. So what is the secret sauce? I'm sorry, but let me find my notes. I call it functor. Yes, it's not biological. This is functor. What functor could be? It could be hormonal gland. hormones gland. It could be substance glands. It could also be stomach cells. And these functors are the magic sauce of my design. What is it? It is an event. No, it is a functor. A functor is an execution, an executable or a scriptable. An execution script. Oh. That manipulate how nodes behaves. What does it mean? Remember when I was talking about no, not this one. When I was talking about this, we will have an event, right? Reinforcement event that can add more axons, or degradation event that will reverse the reinforcement, which means remove axons. So that's functor. So behaves also mean change the state. State change. Sorry. State change. Or it could be extra. It could be extra calculation step. Extra calculation step. And it could also be the actual output. And the real magic is here. The real magic is it can leave residue. This is also a new concept. Like, remember when I say it can, I mean, this residue generator. This residue generator, which means they are something that will persist throughout calculations, throughout inputs, throughout learning iterations. You can say that this is persistent memories, but I cannot say for certain how memories works. So what does this mean? It means also, by the way, this one is output because it gives you acid. No. What does this mean? It means that node It means, well, um, for the signal, axon signal. Before axon signal, I mean axons and dendrite in neural cells, they have synapse, right? So the picture will look like this is hold on. This is axons, and this is dendrite. And there's a lot of dendrite for each one axon. So when these two organs of the cells communicate, they sprinkle some chemical data that induce signal. What does that mean? It means that these portion of the physical things here is exposed to environment. So it's exposed to the environment. It means that if we have special chemical lying around, these chemicals can go and intercept the neuron's communication. Interception. Where's the end? Okay, so that's what I'm aiming for. I want data to be easily manipulated by the environment, and the environment is created and manipulated by the cell itself. I didn't see lots of ML talking about this. I mean, I saw Nvidia was talking about synapse back in like 2015, and I cannot remember what they were talking, but yeah. So we have the interceptors, and the cells, other cell. Here is the other cell. Other cells, or in this case is functor, creates all these. So it's not just like that, but the other neurons should be able to like tell this cell to activate, and this creates chaotic loops that that will like sustain itself or just abolish itself, and creates dynamics of machine learning. But how do I know that the machine learning works? The seven topic. How do I know that it improves? I mean, basically, functor shouldn't uh shouldn't drop table star. Why do why do you see SQL syntax here? Why do you see SQL syntax here? Because this AI will be running on SQL on SQL engine. It will be running on this WAMP server. And my crappy PC, it is a laptop, by the way, and it's secondhand. We'll try to like calculate the entire table for all these rules. Shouldn't drop table star, and this is stability check. Stability check. It's not stability. It's persistency. Persistency check. Now, yeah, that just persistency check, but the growth check is how much energy to generate the same data. So it improves when it use less energy. Use less energy for the same output. The output, well, output is one word. Output. The output is the data stream. And energy is actually the sum of AN, or actually what we should call is the double sum of AN. So so double sum of AN means it basically the file size, the stream size, stream size. See, these are simple enough. I think even entry level programmers who like take a course of 6 months of programming lessons. Like if they had been in a boot camp, they could write the entire system in one night. But um, well, why do I use existing library? Because I haven't heard of this approach. I mean, there might be someone thinking like this and never coded, or maybe they coded it and they just throw it away because it sounds stupid, or maybe they actually tested it and no one no one think it makes sense, no one use it. But this is how the brain works, and it actually easier to calculate in on computer. I will leave here. So see you later. Oops. Oh, how do you write this one? Later? And Merry Christmas. Plus, Happy New Year. Oh. See you later.